Good evening.
Yes, good evening. How are you?
Yeah, I'm good. And you, sir?
Yeah, I'm fine. Thank you. Okay, so did you complete this part using QGIS smallest plugin?
Actually, I created a Euclidean distance
Yeah.
to roads and Euclidean distance to streams, sir. But I'm
Okay.
still calculating a population density. It's
Yes.
not finished yet. Yeah.
Okay. And further,
Yeah.
when it will be completed, then same process. You also
Yes,
try
sir.
to apply and then easily predict using the QGIS smallest plugin. Okay.
Yes.
As well as for other algorithm, mainly random forest, we already applied for the prediction. Okay. So this code, I hope you already get. Yeah.
Yes, prof. Yes, sir.
Okay.
But I would
Yeah.
like to learn SVM and CART, other algorithms as well, sir.
Okay, I will show is discuss about that. Okay. So today's we discuss about that other two algorithms, suppose card
Yes,
and support
sir.
vector machine, how we can easily add. Okay, and then further we try to predict. Okay,
Sir,
and also
before
yeah, please,
Uh, uh, I'm sorry to interrupt
please,
your
please.
explanation. Sir, could you please explain me the pattern of the ANN network, sir?
Okay, with the artificial neural network pattern. Yeah.
Yeah, may I share the screen, sir?
Okay.
Uh, can you see it?
Yeah, I can see.
So, and then uh, can you see the monolith network?
I it show that your
No,
map
no,
QGIS
no,
first map.
no, sir. I think I have to choose this one. I think. Uh, how to share? Maybe this one. This one. Okay. Uh,
Yes, I
just a
can
moment.
see the
Uh,
QGIS
UTS.
and also Google Earth Engine code editor.
It's just a moment, please. Very smallest. I opened it actually. Here.
Okay, got it. Yeah. So it show that Panglas tool.
Yes, sir. Why is it closed automatically? Oh, actually, sir. Okay, let me put it again.
Okay, no
Mm,
problem.
Yes, sir. To the add. I adjusted the geometry to
Yes.
be in the same 47N,
Yes.
and then sir, when I check the correlation between these two variables, it shows a 0.05. Well, what does it mean, sir? Is it a very low correlation between these two variables?
Yes. So it show about that your Pearson correlation. So basically
Yes,
Pearson correlation, it's one kind of statistical application, and using the Pearson correlation we can easily find out that two variable relation. Suppose in this case you input the distance to road and distance to stream. So between these two variable, we find out that the distance to road and distance to stream, we find out this correlation 0.050. Okay, so this is the
yes,
only for the two. Further, if you input the more variable or parameter, then you also
yes,
check about that others, what the correlation is other. Okay, so in this case
yes,
it display the reason only for the two variable correlation we find out in here.
yes, sir. So here, do I need to adjust like here first raster, second raster, just only this?
So in this case we find out that positive, basically Pearson correlation, we find out the three types of value: positive value, negative value, and also zero. Okay,
Yes,
so basically when you find out the zero, it means that there is no correlation. It's totally there is no correlation we find out in here. Okay, so when you find out that negative value, then we find out that this correlation, but when it will be increased, this thing will be decreased, just opposite. opposite. We
Yes,
find
sir.
out that suppose distance to road is increased but distance to stream is decreased, so we find out the opposite when you find out the negative value correlation for any time. And when you find out the positive value, it's indicating about that distance to road and distance to stream, if distance road is increased, distance to stream is also increased.
Yes, sir.
Okay, so in this case we find out that positive correlation, so it means that if distance to road is decreased, then distance to stream is also decreased. If distance to road increased, then distance to stream also increased.
Yes, sir. Okay. So, so I got it. Let me go to the area changes,
Yeah.
and then I change header, update tables. Yes, sir. And
Yes.
then I create change map.
Yeah.
This one is a 042. And then I go to the uh, in one of the Bangladesh publications,
Yeah.
they mentioned that like the area coverage of that their study area is about 1,500 square kilometers. My
Yeah.
study area is about 2,300 kilometers. So I assume like the same neighborhood living rate, and then may I or should I adjust number of samples?
Yes, if you want to adjust this number of sample after checking the validation or also checking the overall accuracy, then further we also try to readjust the number of sample.
Okay. So should I do it now or just run at first?
Okay, run first, then check what happened for your model.
Yes. Yes, sir. I would like to understand. Uh, I would like to. I would like you to explain me how to interpret the patterns and the curves. Sir.
Okay, okay.
Yes, sir. So it's done now.
Okay, so you find out that accuracy 59%. Yeah. Okay, so in this case, we find out this type of curve,
Yes, sir.
and
Right.
this curve here you can see, we find out that two line, one line for the train, another line is for validation. Okay, so basically, learning curve in neural network is a visual representation of the model's performance over the time as it learned from data. Okay, yeah, when using a plugin like Molas and like who is likely aid in analyzing and visualizing the learning curve or model performance, the concept of learning curves remain, we discuss about that. So basically in this case, learning curve basically it represent the two things. One is that training, another is that validation. Okay, mainly what is the training the
Yes.
performance of the model on the training data set. Suppose the performance of the model, so in this case we find out this one line, it's show about the green color, so it indicating about the performance of the model on the training data set different time about the time. You can see here we also said about the I think learning rate. Okay, learning rate we set the 0.001. So this learning rate we set, and further it create this type of, suppose it check 0.001 second later. Okay, every 0.001 second later, and study your data. Okay, and from here it represent the model performance over the time as it learned from data. Okay, and in this case we put here the neighborhood 3 pixel. Okay, and we find out that validation loss, it also called the validation accuracy. So basically the performance of the model on unseen validation data. Okay, first one is that performance training loss or training accuracy. It represent the performance of the model on the training data set. Okay, and second one mainly validation,
Yes.
it represent the model on unseen validation data. Okay, so in this case you can see x axis, basically x axis, horizontally the number of epoch. Okay, we find out the epoch 0, then 20, then 40, then 60, then 100 and
Okay, so
120.
it's
Basically we set here the maximum iteration 120.
sir, I can hear you well.
Yeah, can you hear me now? Can you hear me?
Yes, sir. Okay,
Okay,
now I can hear.
okay.
Yes, sir.
So in this case, the x-axis, it represents the
Just
number
before
of
your voice
epoch.
was not.
Yeah, can you hear me? Hello, can you hear me?
Now I can hear you.
Okay,
Sir?
okay, can you hear me now? Hello.
Yes, now I
Okay, can you hear me? Hello.
Yes,
Okay,
sir.
okay,
Now
I
I can
think
hear you.
some networking issue from my side. Okay, so now it's okay, yeah.
Yes, sir.
Okay, so continue. Okay. So now, in this case, we find out the x-axis. You can see the x-axis. We find out the 0, 20, 40, 60, 80, 100 and 120. So 120, it represents the maximum iteration. We find out the, because we set the maximum iteration 120. Okay, and it represent the iteration through the training data set. In this case we set here the 120, so that's why it create that uh, 20, 40, 60, 80, 100 and 120. And if you check, we input the hidden layer 10. Okay, so we input the hidden layer 10, so that's why it create the, in this artificial neural network it create the hidden layer 10, and further it create the maximum iteration 120. And in the x-axis is it represent the epoch mainly, it's called that iteration through the training data set. Okay, and the y-axis
Yes.
represent the loss of accuracy. Okay, so y-axis it represent the loss of accuracy, it represent the loss of accuracy.
Yes,
and
sir.
and this parameter, basically this type of parameter, we can do overfitting. We find out the three types of pattern in the learning curve. One is the overfitting, then underfitting and optimal learning. Okay, three types of overfitting we find out, or three types of learning curve we find out. So first one is the overfitting, second one is that underfitting, and third one is the optimal learning. Okay, so overfitting, it means that training loss decrease while validation loss start increasing. Okay, so overfitting mainly training loss decrease while validation loss start increase. Okay, and overfitting indicate the model is learning training data too well and falls to generalizes. So in this case, if you check our model, if it indicating the, we find out that data too well and falls to generalization. We find out that you can see train, we find out that it's very train very good, we find out that because it's find out that high value than validation. Okay, so it indicate the model is learning training data too well and fails to generalize. Okay, so it's called the overfitting, and when you find out the overfitting, we find out the low accuracy. In this case, you can see what is the accuracy, find out that I think it's a 58%.
Yes, sir.
Yeah, yeah, so because it's the
And
overfitting.
the overall accuracy is minus 0.00495.
Yes, yes, because it's overfitting. Overfitting mainly training loss decreases while validation loss starts increasing. Okay, as
Yes,
well
sir.
as indicate the model is learning training data too well and falls to generalization. Okay, data is well but falls to generalization. And underfitting, what is the underfitting? Underfitting mainly both training and validation loss remain high and also accuracy is low. Okay, so this is the underfitting, we find out the accuracy also, but always we try to apply the optimal learning. Okay, not overfitting, not underfitting, we try to gain from here optimal learning. Okay, so optimal learning, this is the desired outcome showing good generalization. Both training and validation losses decrease and stabilize, and we find at similar level, we find out the similar level. Okay,
Okay.
so if your dataset artificial neural network overfitting or underfitting, both of case we find out the low accuracy always. If it overfitting or underfitting, all time we find out that low accuracy. But when you gain the optimal learning mainly both training and validation losses decrease or increase at the same time at a similar level. Okay, not high increase or low decrease. In this case, if you show the graph, you can see here sometime we find out the training is very high, but we find out the validation is the low, basically rate. You can compare it, so you can see sometime you find out that the this graph. Okay, so you can see sometimes you also find out it's worked very well. You can see here the train and validation epoch is the same level, but sometime in the, you can see the left corner 0.11, in this case we find out that very high. So it's the
Yes.
overfitting, in here we find out this overfitting. Okay, if it also the same or same level, then we also find out that optimal level. Okay, and when you gain the optimal level, then it also increase your accuracy. Okay, so now how we can find out the optimal level? Okay, so basically, Molas plugin we are used for learning curve analysis. So basically, Molas maybe provide the advanced insight into the learning process because we can easily find out all of practical example if you check it. So one is that we find out the monitoring loss and accuracy. We can easily find out from this graph. This graph, uh, we find out the two curve, one curve for training, another curve for validation. Okay, and we can easily detect the overfitting. Okay, suppose it's overfitting or underfitting or optimal fitting, we can easily get the idea from this graph. Okay, so that's why this graph is very helpful to identify is it overfitting or is it optimal. Okay, so now how I can find out the optimal fitting or optimal level. So basically, Molas could recommend it using learning rate or modify the architecture based on observable learning curve train. So in this case, if you try to check for the learning rate, suppose in this case we find out the 0.001, so you can simply increase the learning rate. Okay, and also try. Okay, suppose for that 0.005 or 0.0010 or 15 or 20, so just you try to increase the learning rate. Okay, because when you increase the learning rate, then it also modify. Okay, we also find out that another curve, our model, our train
Okay.
learn the another pattern. Okay, when I suppose increase the learning rate, so in this case how I can fix the problem? So just simply increase the learning rate, suppose 0.005 or 10 or 15 or 20 or 50, just check. when you find out the more better accuracy, okay, when increase the overall accuracy, and when you find out the
Okay.
optimal level mainly almost same graph, we find out that
Okay.
train and validation at the same epoch, we find out the same epoch or peak at the same point, okay, so it's the similar or optimal. So in this case we find out that overfitting or underfitting. So that's
Yes.
when you modify it, then try to increase the learning rate. So this is the one solution for increase your accuracy. As well as we also do for another one is that in this case we find out the hidden layer. So you also try to,
Sir?
yeah, can you hear me?
Sir? Hello?
Yeah, can you hear me?
Yeah, I could not hear after you said as well as
Okay, okay. So I hope now it's okay. Yeah. Okay. So just when you face
yes,
this
sir.
type of problem, we just need to increasing the learning rate. I hope then we also find out that optimal level of train and validation. Okay, then it also help you to identify for your increase the level. Okay.
Okay. So sir, one question.
Yeah.
So
Please.
overall accuracy, it should be positive value in
Yes. Yes.
in case of optimal learning.
So in this case, overall accuracy basically we find out that negative value. So that's why I think this data set has some problem. Okay, so that's why it show about that negative value. Okay, and validation
Uh,
kappa is also show about that positive value. And overall accuracy for that artificial neural network, I think this value is considered as a positive because it show the and you can see this symbol overall accuracy, but this accuracy you try to increase it. I hope you can simply, so you try, suppose just try to increase the learning rate and then check what happened.
so, sir, is it related to because here you can see my independent variable distance to row, distance to stream.
Yeah.
I created a discrete category of distances. So, is it also related because I just use a default like here less than 272, 272 to 735 meter or something like. Do I need to adjust these specific?
Not need, not need, not need. You don't need to any kinds of classification. This type of distance to road or distance to the stream or dam. Okay, just it just the same. Suppose in it including only for that high and low value or gradient result. Okay, not need to make
Okay.
for classification.
So, sir, may I show you one thing here? I created like this. I ran the CNN network, and then I note down the values of the results of each run here, kappa, or something like that. So,
Okay.
is it useful if I do so?
Yeah, you
I
also
don't know.
use it. So in this time, this is for initial year and also you can final year 2014 2004 input distance to road. Okay, this type of things you also because from here we also calculate about that average kappa accuracy or average overall accuracy also calculate from here.
Okay, okay, sir. And
Or you know,
okay, okay, sir. Then after this, I have to use a cellular automata simulation, right, sir?
yes, yes.
Before going to there, do I need to save samples?
Yeah, if you want to save it, no
Oh,
problem.
okay.
No
Yes,
problem.
sir. And then here, what do I have to do?
So in this case, just simply uncheck the certainty function. It not need,
Oh, okay,
and
sir.
then simply browse. Click on the browse and put the file name. Suppose in this case, put the file name. You can put any file name. Suppose LULC, your prediction year, right? The prediction year, LULC prediction year. Well,
Yes, sir.
prediction for which year? Number.
Um, Tradition for CA.
Okay, you can do it, no problem.
Yes.
Then
And
start.
then,
Now start. Okay, so now it create one a prediction map. Okay, it's create the one prediction map. Suppose what is the interval you try to is 2014 and 2024, so you can find out the map 2034. Okay,
uh,
and after
yes, sir.
creating this map we also check the accuracy also. Okay, so one accuracy for our model, another accuracy for our map.
Oh,
Okay,
yes,
so
sir.
basically one accuracy for our performance model, another accuracy you can see after completing them we also need to click on the validation. So from this validation we also check our accuracy.
Yes, sir. So, sir, actually, this analysis, in which I put a 2004 land cover map and 2014 land cover map.
Yes,
So can I compare the resulted map with the Google Earth Engine based classified land cover map for 2024?